balancing and identifying types of chemical reactions. So let's start off with balancing first. It's important to keep in mind the law of conservation of mass, and that says that matter is neither created nor destroyed. So when we take a look at this chemical reaction right here, so this equation is telling us that we have H2, hydrogen gas. This G over here denotes that it's a gas, plus O2, also a gas, reacting to form water, which is a liquid. So if we take stock of our atoms, we have 2 hydrogen atoms over here and 2 oxygen atoms. But on this side we have 2 hydrogen atoms and only 1 oxygen atom. So we must have a problem because the law of conservation of mass tells us that we can't just lose atoms. So there is a solution. We need to balance the equation by changing the number of molecules, but not the number of atoms in each molecule. So the easy solution, which would be wrong, would be for me to put a 2 over here. So now I have 2 oxygen atoms. But this changes the reaction completely. Now we're not making water, we're making hydrogen peroxide, which is a completely different chemical. But the reaction told me that we're making water. So I need to balance this. So let's take a look at it. We have a deficit of oxygen atoms on this side. So we can change the number of molecules that are made. So the proper thing to do would be to put a 2 over here. So now we have 2 water molecules formed. So this gets rid of the problem that we had with not having enough oxygen atoms. So now we have 2 oxygen atoms and now 4 hydrogen atoms. This creates another problem, but that's easily fixed because we can just put a 2 over there. So now we have 4 hydrogen atoms over here, 2 oxygen atoms, and over here we also have 4 hydrogen atoms and 2 oxygen atoms. But a chemical reaction did happen because we started out with hydrogen gas and oxygen gas and ended up with water. So now let's take a look at the types of reactions. The first type of reaction that we're going to look at is a synthesis reaction. So synthesis just means to make. So in this kind of reaction you have 2 or more starting materials, A and B in our case, going on to form one product, C. So an example of this would be calcium metal reacting with oxygen gas. So notice that it's a solid and oxygen is a gas, to form calcium oxide. So I've already balanced it for us so that we have 2 calcium on that side, 2 calcium on that side, 2 oxygens on this side, and 2 oxygens on that side. Decomposition reactions can be seen as the opposite of synthesis reactions. So you have 1 starting material that breaks down into 2 products. So in our case, C breaking down into A and B. So an example of this would be magnesium carbonate, which is a solid, breaking down into magnesium oxide and carbon dioxide gas. Next off we have single displacement. So single displacement, the name says it all. You have one thing displacing something else. So in our case, let's take a look at D reacting with E and F. D is going to swoop in, kick out F, and bond with E. Example of this can be seen over here. We have hydrochloric acid, HCl. AQ just means it's dissolved in water, reacting with iron metal, which is a solid, to form hydrogen gas and iron chloride. Notice, remember, we need to write hydrogen as H2 because it's diatomic. It's one of the Han and the halogens. But when we're looking at single displacement reactions, another thing we need to keep in mind is the activity series. So the activity series, right here, just lists the metals according to their reactivity, with the most reactive ones on top, lithium in this case, and the least reactive ones on the bottom, gold in this case. So when we're taking a look at a single displacement reaction, like this one over here between sodium fluoride and iron, we need to look at the activity series. If the thing that is coming in our case, iron, is higher up on the activity series, it means it's more reactive and it will react. So iron can replace one of 2 things, either the fluorine or the sodium. If it were to replace the fluorine, we'd end up with sodium iron, which doesn't make any sense because they're both metals and we haven't learned of anything that binds 2 metals. So it must come in and kick out the sodium. So let's take a look at our activity series. Sodium is here, but iron is less reactive. So because iron is lower down on the activity series, there will be no reaction. So you just write NR for no reaction. So we also have double displacement reactions. So you can imagine them as 2 dance partners that switch partners halfway through. So you have A plus B reacting with C plus D. So that switches to A and D plus C and B. So again, just like two dance partners switching partners. So an example of this would be calcium nitrate plus sodium carbonate reacting to form calcium carbonate and sodium nitrate. Notice over here that we formed a solid from two aqueous solutions. So there are three subtypes of double displacement reactions. The first is a double displacement reaction forming a precipitate, which is just a fancy word for saying solid that forms out of a solution. The second is a double displacement reaction forming a gas. This usually happens because you made an unstable product called carbonic acid or H2SO3. The third subtype is a double displacement reaction forming water. This typically happens when you have an acid-base neutralization. So over here I wrote down the examples. So we have sodium bicarbonate, also known as baking soda, reacting with acid. That forms carbonic acid, H2CO3, and sodium chloride. H2CO3, because it's so unstable, breaks down right away to form water and carbon dioxide. So writing this right here isn't entirely correct. We should rewrite it to say that sodium bicarbonate reacts with HCl to form H2O, CO2, and sodium chloride. The third subtype, a double displacement reaction forming water, as is seen in an acid-base neutralization, is over here. So here we have KOH, which is a base, and HBr, which is an acid, reacting to form KBr and H2O. The last kind of reaction we're going to learn about is a combustion reaction. So a combustion reaction needs fuel, and that fuel is usually a hydrocarbon. So hydrocarbons have carbon, hydrogen, as the name suggests, but also sometimes they have an oxygen or two. So this hydrocarbon will react with oxygen to produce CO2 and H2O. If there's enough oxygen fuel in the environment, it forms a complete combustion reaction to form CO2 and H2O only. If there isn't enough oxygen getting to the fuel, then you'll have some side products such as charcoal, just carbon, and carbon monoxide. So for example, in homes, in heating systems, it's important to ensure a good oxygen flow, otherwise you'll form carbon monoxide because there won't be complete combustion. If there is a good flow, then you'll just form CO2 and H2O, which are relatively harmless. So an example here is C4H8 reacting with oxygen to form carbon dioxide and water. Again, it's balanced. For balancing combustion reactions, it's always a good idea to start with the carbon, then the hydrogen, then the oxygen. The reason for that is the oxygen is in both products, so it's a bit harder to balance.